When we think about science, we think about experiments, and that is an important part in science. Maybe when you were in elementary school, you look up for experiments on the internet for your science fairs, or on your textbook you had experiments. You just had to follow the steps. They gave you the question, sometimes maybe the hypotheses, and you just had to get the materials and make the experiment. But now that you are a high school student, you should learn how to design a science experiment. This might sound a little bit complicated, but the truth is that it's a simple thing to do. And on today's video, I'm going to teach you how to design a science experiment. Hi, and welcome back. Suppose you have a fertilizer, and the fertilizer says that if you use it in your plants, they will grow faster. How can you prove that? Well, you have to design a control experiment. A control experiment is a scientific test where you keep all the variables constant except the one you're going to test. In this case, the one I'm going to test is the fertilizer. So I will apply the fertilizer in one plant and I won't apply fertilizer to the other plant. Later on with the example, I'm going to explain the types of variables. Now, we need to write down a hypothesis. Remember what is a hypothesis? It's an educated guess or a prediction. We usually use words like if and then. So, if I use fertilizer in plant A, then it will grow faster than plant B. So this is a correct way of writing a hypothesis. Now, how can I prove if my hypothesis is correct? Designing an experiment, and I'm going to show you how to do it. As I mentioned before, we're going to use the fertilizer in one plant and in the other not. So to design the experiment, obviously we're going to need two plants. If I want my experiment to be accurate, I should use the same type of plant. Also, we're going to place them on a similar size pot and we're going to put the same amount of dirt or soil. And we need to water the plants at the same time every day. I will also place both plants next to each other in the same place. Every day, I will have to measure if the plants are growing or not. And as a good scientist, I must keep a daily record of how much does each plant grow. I can do it by week, or I can do this by a month or 2 months. With that information, I can even create a graph where I compare the growth of both plants. This is my data. Now that you finish with your experiment, you can prove if your hypothesis was correct or not. If the hypothesis was correct, that means that plant A grew faster than plant B. Now, what will happen if the hypothesis was incorrect and both plants grew at the same time? Well, you learned something. It doesn't mean that the experiment is wrong. Maybe the fertilizer, if you make a research, you find out that the fertilizer works only on vegetables and not ornamental plants. Now let's talk about the variables. I mentioned that I will explain this with the same experiment. There are three types of variables. We have independent variable, dependent variable, and control variables. The independent variable is the thing that changed. So what was different from plant A and plant B? That I applied fertilizer to one plant and I didn't apply fertilizer to the other. So the fertilizer is my independent variable. The dependent variable is the thing we're measuring. What were we measuring? How much did the plant grow? That was my dependent variable. And the control variables were things like the size of the pot, the amount of soil, the place where the plants were. So those things, I control them. Okay, so those are the control variables. Well, now is your turn to practice how to design a science experiment. But before that, I want to make a review of the main ideas for this video. Now, based on that question, does sugar dissolve more quickly in warm water or cool water? You are going to design a science experiment. It's going to be a simple experiment. I just want to see if you are able to follow the steps that I just explained. So, based on that question, you're going to write down your hypothesis, an educated guess or prediction. That is the first step. So remember to use words like if and then. Once you have your hypothesis, make a research. What affects the rate of dissolving in substances? Or does temperature affect the rate of how sugar dissolves in a substance? You can research this in the internet, in magazines, or in books. Once you have done your research, it's time to make the experiment. What materials do you need for your experiment? You have to be very specific with the amount. For example, how much water you're going to use. Are you going to use 1 cup of water or 1 glass of water? How much sugar? Remember, you need to place the same amount of sugar. 1 spoon of sugar, for example, or 2 spoons of sugar. Then you're going to make that experiment. And remember that as a good scientist, you need to keep a record. So you can do something more simple than this one, right? Like, how long did it take for the sugar to dissolve in cool water? So you can count the time. Maybe it can be seconds, okay? So how many seconds that it took to the sugar to dissolve in cool water? And then you're going to compare how many seconds does it took for the sugar to dissolve in warm water. Once you have that, you can even create a graph like this one or other type of graph comparing your results. So down here, you can write the seconds. So for example, warm water took 3 seconds until here. So I'm going to make a line until here. And maybe in cool water, it took 7 seconds. So I'm going to draw a line until here to represent cool and warm water and how fast the sugar dissolve on them. Once you have that, you can write down your conclusions. Remember to use phrases like I learned with my experiment, I learned that sugar dissolves faster in, and you write down what is the results. You can also explain if your hypothesis was correct or not. And of course, I'll be giving you feedback on your work. Well, I hope you find this video interesting. If you like it, please give it a thumbs up. And until the next one, bye!